Welcome to lesson 4.2, Graphing Linear Equations. So in our last lesson, we looked at coordinates and scatter plots to help you remember some of the terms and different ways to plot points on a coordinate grid or a coordinate plane. Now in this lesson, we are going to look at the idea of graphing linear equations and the solutions to these equations. So simply put, a solution of an equation. So a solution of an equation is an ordered pair, meaning your x and y values or coordinates, that makes the equation true. So any ordered pair that makes the equation true is a solution. The graph of an equation is the set of all points or all ordered pairs, x and y, that are solutions of the equation. So a single ordered pair that makes the equation true is a solution. A graph is the set of all of those different solutions. So in example 1, we're simply going to look at, is the ordered pair a solution of an equation? And in this case, the equation is 2 times x plus 3 times y equals -6. So in A, they want us to check the ordered pair 3, -4. So remember, ordered pairs always go x comma y. So we'll substitute the 3 in for x and the -4 into y. And we'll be substituting those in to our equation here. So that equation becomes 2 times 3 plus 3 times -4 equal -6. And we're checking if that's true. So 2 times 3 is 6. 3 times -4 is a -12. And on the right, we still have -6. So 6 plus a -12 equals a -6. If we simplify the left, 6 plus a -12 is -6. So -6 equals -6 is true. So that means that this ordered pair is a solution to that equation, meaning that ordered pair would be on the graph. For B, we have -4, 1. So substitute the -4 in for x and the 1 in for y. So we end up with 2 times -4 plus 3 times 1, and we're seeing if that equals -6. So on the left, -8 plus 3, which is a -5. -5 does not equal -6, so that tells us the ordered pair, -4 comma 1, is not a solution to that equation, meaning that point would not be on the graph of the line. So then, practicing with 2 more examples here, we're going to use the points 1, 4 and 3, -4, and we're checking these two to see if they are solutions to the equation 4x plus y equals 8. So we'll substitute the 1 in for x and the 4 for y. 4 times 1 plus 4. We're checking, does that equal 8? 4 plus 4, which is 8. 8 equals 8, meaning this is a solution to that equation. Do the same with the 3, -4. 3 in for x, -4 in for y. 4 times 3 is 12. Minus 4 is 8. So 8 equals 8. The ordered pair, 3, -4, is a solution. So to check if you have a solution, you substitute the ordered pair in for x and y for the equation. Then we're getting to our steps to graph a linear equation. And remember, the term linear equation just means the graph will be a line. So the first thing they want us to do is rewrite the equation in function form. So that means solve for y or get y alone. So if it's not already written in slope-intercept form, which we'll look at more, but written to solve for y, we need to get it and rewrite it to solve for y. Then you make a table and you choose at least 3 values for x. You put those numbers into the equation for x to find y. Plot the points from the table to draw the line that goes through the points. So let's look at a couple examples of those steps. So in part A, our equation is y equals 2x minus 3. It's already solved for y, or written in what we call function form. So then I can just choose at least 3 values to substitute in for x to find out y. So I set up my simple 2-column table, and for x, I'm putting in a 0, 1, and 2. When I put a 0 in for x, 2 times 0 is 0, minus 3 gives me a y value of negative 3. When I put a 1 in for x, 2 times 1 is 2. 2 minus 3 gives me a y value of negative 1. Then when we put a 2 in for x, 2 times 2 is 4. 4 minus 1 is 1. So now I have my 3 ordered pairs to graph. Over 0, down 3. Right 1, down 1. Right 2, up 1. So always starting at the origin, over 0, down 3, there's that point. Over 1, down 1, there's that point. Over 2, up 1, there's that point. Connect your 3 points to draw your line. In B, our equation is not written in function form. It's written as x plus 4y equals 4, which you'll see in a later lesson we call standard form. So we want to get that into function form, so we need to solve for y. So if x plus 4y equals 4, we can start to solve for y by subtracting x from each side. That would give us 4y equals negative x plus 4, or 4 minus x. Then I'm going to divide everything by 4. So then, to get y alone, 4y divided by 4 is y. A negative x divided by 4 is a negative 1/4 x, or x over 4. And then the 4 divided by 4 at the end gives us a plus 1. So in this case, our function form equation is y equals negative 1/4 times x plus 1. So now when I choose my values for x, if I'm dealing with a fraction here, I don't want to graph fractional values. It's okay to do that, I just don't want to deal with it. So when I'm choosing numbers to put in for x, to avoid a fraction, I'm going to choose numbers that can be divided by the denominator of 4. So I don't want to use 1 or 2. I'm going to use 0, 4, and 8. So if I put a 0 in for x, 0 times anything is 0, plus 1 gives me the output of 1. So my first ordered pair, over 0, up 1. Then I'm going to put a 4 in for x. 4 multiplied by a negative 1/4. So 4 divided by 4 on bottom is 1. Multiplied by the negative 1 on top is just negative 1. So we'd have a negative 1 plus 1, which gives me 0. So the next value is 4, 0, right 4, up or down 0. Then if I put an 8 in there, 8 times a negative 1/4 is a negative 2, plus 1 back would give me a negative 1. So that would be right 8, down 1. Right 8, down 1, right at the end of our graph over here. Or, if you run out of space, we could put in a negative 4 for x. If I put a negative 4 in for x, negative 4 times negative 1/4 is a positive 1. plus one more would be 2. So -4, 2 would be left 4 up 2. Connect your points, and you have your line. So then we're going to practice with 2 more of these. So our first equation in A is already in function form, y equals -2/3 x plus 5. What I notice is the fraction attached to x, so I want to put in numbers that can be divided by the bottom. So I'm going to use 0, 3, and 6. 0 times anything is 0, plus 5 would give us a 5. So over 0, up 5. If I put a 3 in here, 3 times a -2/3 is a -2, plus 5 would be a +3. And then if we put a 6 in there, 6 times a -2/3 would give us a -4, plus 1 is a +1. So our points over 0 up 5, over 3 up 3, over 6 up 1. Connect the points and you have your line. And then for B, we need to first rewrite this to solve for y or to write it in function form. So I would subtract x from each side, and I have -2y equals a -x plus 4. Divide everything by the -2, and y would equal 1/2 x minus 2. So now when I select numbers for x, I want ones that can be divided by 2. So I'm going to put in a 0, 2, and 4. 0 multiplied by anything is 0. Minus 2 gives me a -2. Half of 2 is 1. 1 minus 2 is a -1. Half of 4 is 2. 2 minus 2 is 0. So now I have my 3 coordinates, or 3 ordered pairs. Over 0 down 2, over 2 down 1, and over 4 down 0. Connect your points, and you have your line. And then the last example we're looking at today are special cases. So these would be the equations of vertical and horizontal lines. The graph of any horizontal line will simply be y equals a number. There is no x. The graph of any vertical line is x equals a number. There is no y. So in example 3a, if I'm graphing y equals -3, that's a horizontal line through -3. If I'm graphing x equals 2, that's a vertical line through +2. X equals -5, so that would be a vertical line through -5. And y equals a +4 would be a horizontal line through the +4. Again, you can ignore the problem numbers down here. Use the ones that are in Google Classroom. These were for my summer school course.